A silent stone giant holds mathematical secrets we only just learned to name. The Great Pyramid of Giza is far more than an ancient tomb. It is a complex equation built on a colossal scale. By the end of this journey, you will see this world wonder not just as a pile of rocks, but as a sophisticated mathematical model. How could a civilization without modern tools encode constants like pi into their architecture? And why did they align its corridors with specific stars? What does this tell us about the true purpose of this legendary structure? How does our own understanding of genius change when we look at the past? The pyramid's sheer scale can be intimidating, a mountain of stone that seems to defy simple measurement. Yet to understand its mathematical soul, we must first look at its physical body, its core dimensions. This is not about abstract numbers, but about the very real lengths and angles chosen by its builders. The original base length was not a rough estimate, it was a meticulously planned figure, repeated with astonishing consistency across all four sides. Each side stretches approximately 756 feet, a measurement so precise that the difference between the longest and shortest sides is less than the length of your hand. This alone speaks to a level of control and intention that goes far beyond simple construction. Then there is the angle of inclination, the specific slope at which the sides rise to meet at a point high above the desert. This is not a random steepness, it is a consistent 52-degree angle, a figure that appears again and again, carved into the very geometry of the structure. Why does this matter? Because these two numbers, the base length and the slope, are the fundamental ingredients. They are the primary data points, the simple equation from which an entire universe of mathematical relationships would eventually emerge. This foundational accuracy is the canvas, and everything that follows, every secret and every alignment, is painted upon it. Without this stable, intentional baseline, the more intricate patterns we will explore would simply fall apart. The builders gave their creation a perfect, proportional form first, ensuring that its deeper messages could be written in a language of stone and angle. This foundational accuracy sets the stage for one of the pyramid's most enduring mathematical whispers, the appearance of the constant pi. Take the pyramid's original perimeter, the distance you would walk around its base, and compare it to twice its original height. The resulting figure is not a random number, it is a value that comes incredibly close to 3.1416, the number we know as pi. This is not a coincidence later observers forced onto the structure. This relationship emerges directly and inevitably from the specific 52-degree slope the builders so carefully established. So how did a civilization that left us no symbolic equations for pi seemingly encode it into stone? The answer likely lies not in numbers but in a beautifully simple physical action. Imagine rolling a wheel. If you mark a point on its rim and roll it one full revolution along the ground, the distance it travels is its circumference, which is pi times its diameter. Now picture a wheel whose diameter is exactly the height of the pyramid. If you rolled that wheel, its circumference would be pi times the height. Astonishingly, the perimeter of the pyramid's base is very nearly twice that distance. It is as if the builders used the turning of a circle, a fundamental mechanical motion, to define the square footprint of their colossal structure. This was not about calculating pi to 100 decimal places. It was about embodying a fundamental relationship between a circle and a square through practical, repeatable geometry. They were not writing an equation, they were building one, using the world itself as their calculator. This elegant fusion of forms hints at a deeper, more symbolic purpose. a way of uniting earthly and celestial ideals within a single monumental shape. But the circle was only the beginning of their geometric language. Another profound principle seems etched into the pyramid's very angles, a number so revered it has been called divine. This is the golden ratio, often symbolized by the Greek letter phi. It is a special relationship, approximately 1.618 to 1, that appears repeatedly in nature, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. It is a proportion that the human eye inherently finds beautiful and harmonious, and the Great Pyramid appears to be a massive monument to this very idea. To see it, we look at two key measurements. The first is the apothem, which is the slant height running from the pyramid's tip straight down the center of one of its triangular faces to the middle of the base edge. The second is half the length of the base itself. When the apothem's length is divided by this half base, the resulting number is remarkably close to phi. This is not a vague approximation. It suggests the builders intentionally shaped the entire structure around this perfect proportional relationship. Why would they go to such extraordinary lengths? This moves the discussion far beyond simple construction and into the realm of sacred geometry. It implies the pyramid was not just a tomb, but a physical manifestation of a universal ideal. By encoding the golden ratio, they were aligning their work with the same principles of balance and growth seen throughout the natural world. They were building a mountain that echoed the perfection of a flower, creating a permanent, silent hymn to the mathematical harmony they perceived in the cosmos itself. This was architecture as philosophy, stone expressing a deep, fundamental truth about the order of the universe. Such profound geometry demands an equally profound method of construction. How do you translate a perfect mathematical idea conceived in the mind onto a landscape of millions of stone blocks? The answer is not found in lost super technologies, but in the brilliant application of simple, elegant tools. Imagine a long, knotted rope, a standardized measuring cord that ensured every worker, from the lead architect to the quarryman, was building to the same exact scale. This was their fundamental unit, their living ruler. To achieve a perfectly level base across an area of 13 acres, they likely used water. By carving shallow trenches across the bedrock and filling them with water, they created a universal horizontal plane. A mark on the trench wall would show the exact water level, and any stone could be cut down to meet that perfect line. This was ancient ingenuity at its finest, using the immutable laws of nature to solve a problem of colossal engineering. For aligning the pyramid's sides to the cardinal directions with an error of less than 1/15 of a degree, they turned to the stars, simple sighting rods, aligned on the unchanging North Star or the arc of specific circumpolar stars, would have provided a celestial reference point far more accurate than any magnetic compass. The true genius was not in the complexity of the tools, but in the sophisticated knowledge of how to use them. It was the understanding of geometry, astronomy, and physics that transformed a rope and a bowl of water into instruments of unparalleled precision. This reveals a powerful truth about human innovation. They did not need advanced machinery because their intellectual framework was so advanced. They could look at a bucket of water and see a universal level. They could look at the night sky and see a perfect square on the ground. This is the heart of their achievement, a reminder that the most powerful tool in any era is the educated, observant, and creative human mind. This celestial alignment is a mathematical signature written across the desert floor. The builders did not merely aim for north, they defined it with an accuracy that challenges modern understanding. Each side of the pyramid faces a cardinal direction with an error of less than 1/15 of a degree. Think of that for a moment. A full circle has 360 degrees, so this error is smaller than the width of a pencil held at arm's length. This was not achieved with a simple compass, but through a deep and patient observation of the heavens. They likely used the constant, unchanging path of specific stars, tracking their arc across the sky to find a true meridian line. This gave them a perfect square on the ground, a foundation aligned with the very axis of the world, but the alignment goes far deeper than the base. Look up at the pyramid's core, at the narrow shafts that climb from its inner chambers. These are not random air vents. One set points directly toward the belt of the constellation Orion, a grouping of stars central to Egyptian beliefs about the afterlife and rebirth. Another set was aimed precisely at Theban, the star that served as the North Pole star during that ancient era. This transforms the pyramid from a simple geometric shape into a complex instrument frozen in stone. It becomes a three-dimensional map, a permanent link between the landscape of Egypt and the territory of the night sky. The mathematics of its slopes and the astronomy of its alignments are two expressions of the same unified vision. This was a structure designed to capture a moment in cosmic time, to harmonize the measure of the Earth with the motion of the stars. What were they trying to accomplish by building this bridge between worlds? The answer may lie in the ultimate purpose of the entire endeavor, a purpose that goes far beyond a simple final resting place. Every single measurement of the Great Pyramid, from its vast base to its towering height, was defined by one master unit, the royal cubit. This was not a vague approximation like the length of a man's forearm. It was a meticulously standardized measure, approximately 20.6 inches long, and it holds a secret far grander than its size. The cubit's own length may have been derived from the Earth itself. If you take the polar radius of our planet, the distance from the center to the North Pole, and divide it by exactly 25 million, the result is strikingly close to the length of the royal cubit. This suggests the builders were not just measuring local stones, they were scaling down the entire world into their architectural plan. This transforms the cubit from a simple wooden ruler into a unit of global, even cosmic, significance. It was a terrestrial meter stick derived from a planetary dimension. How did they standardize such a precise unit across a vast kingdom? The answer lies in the power of central authority and meticulous craftsmanship. Master cubit rods carved from durable black granite were the ultimate reference. These were duplicated with extreme care and distributed to overseers and work crews, ensuring that a block quarried hundreds of miles away would still fit perfectly into the rising structure. This was a triumph of ancient metrology, the science of measurement, but this system reveals something even more profound about their worldview. The cubit was not an arbitrary length. It connected the human scale, the measure of a pharaoh's monument, directly to the scale of the planet. This reflects a philosophy where the microcosm and the macrocosm were intimately linked. Building with the cubit was an act of aligning human creation with the fundamental proportions of the earth. It was a way of saying that the king's eternal home was not just in Egypt, but was, in a very real geometric sense, a miniature model of the world itself. This interconnected thinking raises the ultimate question: what was the true purpose of embedding such profound and layered meaning into a single, silent monument? This geometric mastery extends to a principle so fundamental we often credit it to a man who lived 2,000 years later. The shadow of Pythagoras falls across the desert long before his time. Look at the pyramid not as a solid mass, but as a simple triangle, the shape you see when you slice it directly down the middle. This cross-section forms a massive, elegant triangle. Now take its key dimensions. The height acts as one side, half of the base length acts as another, and the slanting apothem we discussed earlier is the longest side, the hypotenuse. The ratio between these three lengths is not a random assortment of numbers. They align perfectly with the proportions of a 3, 4, 5 triangle. This is the simplest and most famous example of a Pythagorean triple, where the squares of the two shorter sides add up to the square of the longest side. Here, the numbers 3, 4, and 5 are not literal measurements, but a proportional rule, a perfect recipe for creating a right angle. This knowledge was not written down in a textbook. It was built into the very bones of the pyramid. For the builders, this 3, 4, 5 relationship was a practical godsend. How do you ensure that the corner of a mountain-sized building is perfectly square? You use this unshakable geometric rule. By laying out triangles with these precise proportions on the ground, they could check and recheck their angles throughout the decades of construction. This guaranteed the structure's stability and its iconic, flawless form. It demonstrates a working, hands-on understanding of triangular geometry that was absolutely essential. They did not need to name the theorem to understand its power. They used it to build something meant to last for eternity. This practical application of deep mathematical truth raises a compelling question about the nature of knowledge itself. How many other profound understandings of the world were discovered, used, and then lost, only to be rediscovered and named by a different culture millennia later? The pyramid stands as a silent testament to an advanced practical mathematics, a knowledge written not on papyrus but in the enduring language of stone and angle. This specific 52-degree angle was not found through trial and error. It was calculated using a brilliant and uniquely Egyptian mathematical tool known as the Seked. Forget complex trigonometry. The Egyptian architects thought in terms of a simple, elegant ratio. The Seked is defined as the horizontal run of a slope for every 1 cubit of vertical rise. For the Great Pyramid, the chosen Seked was 5.5 palms per cubit. This means for every cubit the pyramid rose upward, its face would step outward by 5.5 palms. You can picture this as a master builder holding a cubit rod vertically and then measuring out 5.5 hand widths to the side to set the perfect slope for the entire structure. This single, repeatable ratio is the mathematical seed from which the entire colossal form grew. It is the direct reason we see that iconic 51.84-degree angle, a figure that modern surveys confirm with awe-inspiring precision. This was a deliberate, formulaic choice, a standardized recipe for monumental construction. The Seked system reveals a culture that had systematized architecture itself. It was a practical, scalable solution that allowed thousands of workers over decades to consistently execute a single, unified geometric vision. This transforms our understanding of the pyramid from a mysterious wonder into a masterfully engineered project. We are not looking at magical guesswork, but at the application of a rigorous and brilliantly effective design code. What other secrets might be locked within this simple, ancient formula for building perfection? This geographic precision adds a planetary scale to the pyramid's genius. The structure does not merely face north, it occupies a location of profound global significance. The Great Pyramid sits at the exact point where the longest land meridian, the line of longitude running from pole to pole over the most continuous stretch of land, intersects the longest land parallel, the line of latitude that crosses the greatest amount of continental territory. In the context of the ancient world's known landmasses, this spot was the geographic center of their entire Earth. Was this an incredible cosmic coincidence, or was it the ultimate expression of their intent? The sheer unlikelihood of such a perfect placement suggests a level of global surveying knowledge that seems almost impossible for the era. Imagine the generations of exploration, the mapping of coastlines and mountain ranges required to even conceptualize such a central point. This was not a monument placed for convenience, it was anchored to the planet itself. This transforms our understanding of its purpose once more. The pyramid was not just aligned with the stars above, it was pinned to the very heart of the world below. It becomes a geodetic marker, a fixed point in a vast, unknown world. By building at this calculated center, the creators were making a profound statement. They were asserting that their king's eternal home, this model of cosmic harmony, was the literal and symbolic pivot of all creation. The mathematics of its form, the astronomy of its shafts, and now the geography of its foundation, all converge into a single, unified vision. This was a project designed to unite earth and sky, placing a human masterpiece at the very nexus of the universe as they understood it. A problem that would baffle scholars for centuries appears to have been solved in stone long before it was ever written down. The challenge is known as squaring the circle, a quest to create a square with the exact same area as a given circle using only a compass and a straight edge. For ages, this was the ultimate geometric puzzle, one that would eventually be proven mathematically impossible in the modern sense. Yet the Great Pyramid seems to present a breathtaking conceptual solution. Consider the pyramid's height as the radius of a theoretical circle. If you calculate the circumference of that circle using the formula 2 times pi times the radius, you get a specific length. Now look at the pyramid's base perimeter. The two measurements are strikingly similar. It is as if the builders used the height to define a circle in space, and then shaped the square base to match that circle's boundary. This is not a literal, mathematical squaring of the circle in the strictest Euclidean sense, but a monumental symbolic representation of the idea. The perfect circle and the perfect square, two fundamental shapes representing the celestial and the earthly, are harmoniously unified within a single, stable form. Why would they encode such an abstract and advanced concept? The pyramid was likely far more than a tomb. It was a philosophical statement. It was an attempt to resolve a fundamental duality, to show that the order of the heavens and the order of the human world could be brought into perfect proportional balance. By building this ideal, they were not just stacking blocks, they were attempting to capture a universal truth in limestone and granite, creating a permanent answer to a question that would echo through the ages. Step inside the pyramid's shadowed heart, and you will find its mathematical soul is still beating. The same genius that shaped its colossal exterior was meticulously carved into every inner passage and chamber. This is not a hollow mountain, but a complex instrument of stone where even the air you might breathe follows a geometric rule. Consider the king's chamber, a room of stark, overwhelming power. Its dimensions are a perfect expression of the 2-to-1 ratio, its length exactly twice its width. This was not a random choice for a sarcophagus room, it was a deliberate application of sacred geometry. This specific proportion creates a space of profound harmonic resonance, a concept the builders understood not as sound waves but as a fundamental balance. The chamber becomes a geometric anchor point within the vast structure, a stable, rectangular core from which the entire pyramid's energy, both physical and symbolic, seems to radiate. Then there are the narrow shafts, often misnamed as simple air vents. Their angles are not functional afterthoughts, they are precisely calculated trajectories aimed at specific stars. But their cross-sections are mathematical puzzles too, their dimensions forming ratios that echo the same principles of harmony found in the chamber they serve. The entire internal layout operates like a three-dimensional circuit board, where every corridor's slope, every chamber's volume, and every shaft's angle is a defined variable in a grand, unified equation. What does this integrated design tell us? It means the pyramid was conceived as a single, cohesive entity. The outside was not a shell built around a separate interior. Both were designed together as interdependent parts of a whole. The exterior captures cosmic relationships with the Earth and stars, while the interior models a more intimate, symbolic universe. This was a machine built not for physical labor, but for a philosophical purpose, its every passage a sentence in a long, silent argument written in stone, arguing for a universe governed by number, proportion, and an unshakable celestial order. Yet the silent perfection of the pyramid's geometry speaks of another, more human kind of genius. Behind every precisely placed stone stood a vast, living machine of people. Organizing this workforce was a mathematical puzzle of staggering complexity, a feat of logistics that rivaled the architectural design itself. We are not talking about a simple crowd of laborers, but a highly structured, meticulously managed operation. This required a sophisticated administrative system capable of calculations we might associate with modern project management. Think of the basic needs alone. How much food and water must be supplied daily to sustain 20,000 people in the desert? How many cattle, how much grain, how many pots of beer? This was not guesswork. Scribes would have performed constant, large-scale computations to determine rations, track supplies, and manage a distribution network that stretched the length of the Nile. This was mathematical genius applied to human survival, ensuring the workforce itself remained a stable, functioning tool. Then came the scheduling. Quarrying, transporting, and placing millions of multi-ton blocks required a carefully choreographed sequence of tasks. Teams had to be rotated, their work synchronized so that haulers arrived just as the ramp systems were clear, and masons were ready to precisely set each new course of stone. This demanded an advanced understanding of time and motion, of how to break down a colossal goal into thousands of smaller, manageable operations, each with its own timeline and resource requirement. The project managers were effectively running a complex algorithm, one written not in code, but in daily work orders and seasonal labor cycles. This reveals a truth often overshadowed by the stones themselves. The true wonder is not just that they built it, but that they organized the building of it. The administrative and logistical mathematics required to execute such a perfect design demonstrates that the genius of the pyramid was a distributed intelligence. It lived in the architects who conceived the Seked, in the scribes who calculated the bread, and in the foremen who coordinated the teams. This was a society that had mastered the art of large-scale computation, turning the chaotic variables of human endeavor into a precise, coordinated force that could shape a mountain. The pyramids form whispers of a deeper rhythm, a pattern of growth we often see in the living world. Look at the spiral of a seashell or the unfolding petals of a flower, and you will find a mathematical signature known as the Fibonacci sequence. This is a series of numbers where each new term is the sum of the two preceding it, beginning with 0 and 1. The sequence unfolds as 0, 1, 1, 2, 3, 5, 8, and so on, expanding in a perfect recursive pattern. While we cannot find the Fibonacci numbers literally etched into the pyramid's dimensions, the principle they embody, this idea of additive, organic growth, is deeply resonant with the structure's creation. The entire project was a cascade of logical, accumulating steps, one block laid upon another, one course of stone setting the foundation for the next. This was not a random piling of rocks, but a systematic, layered progression, much like the way a plant adds new leaves or branches according to a built-in efficient blueprint. The builders may not have written down the Fibonacci sequence, but they appear to have intuitively grasped the fundamental logic it represents, the same logic that nature uses to build complex, stable, and beautiful forms. Why would this matter to them? It suggests they saw their work not as separate from the natural order, but as an extension of it. by constructing a mountain that followed the same underlying principles of growth as a pine cone or a sunflower. They were aligning human ambition with the universal mathematics of life itself. This man-made geometry was their way of echoing a cosmic pattern, creating a permanent monument that feels as organically inevitable as it is intentionally magnificent. For the architects of the pyramid, mathematics was a sacred language. Numbers and shapes were not cold abstractions. They were the living fabric of the universe, deeply woven into their spiritual beliefs and their understanding of a principle called math. Math was the ultimate cosmic order, the harmony that held the stars in their courses, made the Nile flood predictably, and ensured the cycle of life, death, and rebirth. It was truth, balance, and justice made manifest. In this worldview, building something as monumental as the Great Pyramid was not merely an engineering project, it was a profound act of cosmic maintenance. The pyramid was conceived as a machine for sustaining math, a permanent anchor of stability in the world. This is why its precise proportions were not a matter of aesthetic preference. They were absolutely essential to its function. A single angle slightly off, a ratio imperfectly expressed, would render the entire structure spiritually inert, a broken machine unable to perform its sacred duty. The meticulous application of the Seked, the encoding of pi and phi, and the perfect cardinal alignment were all acts of devotion. They were the necessary rituals performed in stone to ensure the pyramid resonated correctly with the fundamental frequencies of the cosmos. This transforms our understanding of every measurement. The builders were not just skilled technicians, they were priests of geometry, and their calculations were prayers. The mathematical genius we admire today was for them a form of spiritual obedience, a way of binding human creation to the eternal and unshakable order of the universe. Before the Great Pyramid's perfection, there was an experiment in stone that changed everything. To understand the anonymous master who designed Giza, we must first look to a man whose name echoes through history, Imhotep. He served the pharaoh Giza nearly a century before the Great Pyramid rose, and he was so much more than a builder. Imhotep was a true polymath, a high priest, a renowned physician, and the world's first recorded architect. His legacy provides the essential blueprint for the kind of mind that could conceive of such a monumental project. His masterpiece, the Step Pyramid at Saqqara, was the very first pyramid ever constructed, a revolutionary leap from simple mud brick tombs to an eternal mountain of cut stone. This was not just a new shape, it was a new idea, a declaration that human ambition could be rendered permanent through mathematics and engineering. Imhotep's genius lay in his synthesis of disciplines. His knowledge of astronomy informed the pyramid's alignment. His understanding of medicine and the human body perhaps influenced its symbolic proportions, and his priestly duties ensured its sacred geometry was a true expression of cosmic order. He established the foundational principles, the intellectual and artistic traditions that an entire civilization would spend generations refining. The Great Pyramid, therefore, is not a sudden miracle. It is the ultimate expression of a long evolving scientific and artistic tradition. It is the final, flawless product of a culture that had been perfecting the art of stone, the science of measurement, and the philosophy of sacred space for over a century. By studying Imhotep, we see the Great Pyramid not as an isolated anomaly, but as the magnificent pinnacle of a journey that began with a single, brilliant mind taking the first step. This final geometric leap is perhaps the most breathtaking of all. We have seen how the pyramid models circles and encodes universal constants, but some researchers propose its ambition was even grander. They suggest the entire structure is a scale model of the Northern Hemisphere itself. Consider the fundamental ratios. The pyramid's original height stands in a specific proportion to the perimeter of its base. If you then take the Earth's polar radius and compare it to the circumference at the equator, the two ratios are strikingly similar. It is as if the builders scaled down the planet by a single, consistent factor, condensing a global dimension into a local monument. This is a highly controversial idea, yet it forces us to confront the sheer scope of their possible knowledge. To achieve such a correlation, even symbolically, would require a remarkably accurate understanding that the Earth is a sphere and a sophisticated grasp of its size. This transforms the pyramid from a geodetic marker, a point on the map, into a geodetic model, a representation of the map itself. The structure is no longer just aligned with the world, it becomes a miniature version of it. What could possibly motivate such an immense symbolic act? It pushes the boundaries of the pyramid's purpose to the absolute limit, suggesting its true function was to serve as a permanent, physical anchor for the cosmic order of the entire known world. The king's house was not merely at the center of the Earth, it was the Earth in microcosm, a perfect stone echo of the spinning globe it stood upon. Yet the mathematical soul of Giza was not born in a vacuum. Across oceans and continents, other ancient cultures raised their own pyramidal forms, creating a fascinating global echo of this fundamental shape. When we place the Great Pyramid beside the stepped temples of Mesoamerica or the steep-sided pyramids of Nubia, a compelling story emerges. It is a tale of both shared human instinct and strikingly different intellectual paths. All these cultures, separated by vast distances and with no possible contact, were independently drawn to the stability and symbolic power of a pyramidal base. They each recognized that a structure rising to a point could bridge the earth and the sky, serving as a platform for ceremony and a marker of cosmic belief. But the specific geometry they chose reveals their unique worldview. The pyramids at sites like Teotihuacan in Mexico are defined by a series of stacked vertical layers. Their grandeur comes from the repetition of a single, powerful form, creating a massive staircase meant for ritual ascent. The mathematics here is often based on calendar counts and astronomical alignments, a different kind of cosmic language. In contrast, the smooth, sharply angled Nubian pyramids feel like a direct, yet distinct, response to the Egyptian model. They share the iconic shape but express a different proportional sense, often with a much steeper incline. This global comparison does not diminish the genius of Giza, it refines it. By seeing what others built, we can isolate what makes the Great Pyramid so exceptional. It is not merely the form, but the obsessive, unified mathematical intention behind it. The Egyptian approach was not just about building high, it was about encoding a complete system of knowledge into a single, seamless geometric ideal. Where others built impressive platforms, the Egyptians built a perfect equation. This perspective shifts our focus from the universal human urge to build mountains to the specific, unparalleled intellectual culture that could calculate a mountain into existence. But the mathematical blueprint of Giza may not end with the pyramids themselves. Look beyond the great stone triangle to its silent, monumental guardian. The great Sphinx, with its lion's body and human head, does not merely share the same desert plateau. It may be an integral part of the same grand geometric equation. The distances and precise alignments between these colossal structures suggest they were conceived as a single, unified complex, a vast architectural sentence written across the sand. The Sphinx is not randomly placed. Its eastern gaze is fixed with purpose, and its position relative to the pyramids creates a series of specific angles and proportions on the landscape. Researchers have noted that the lines drawn between the centers of the three main pyramids and the Sphinx form relationships that echo the same sacred geometry found in the structures themselves. Could the entire Giza plateau be a scaled map of the stars in Orion's belt, with the Sphinx representing a corresponding celestial body like the constellation Leo. This is a compelling, though debated, theory. It proposes that the builders were not just aligning individual buildings to the sky, but were recreating a segment of the cosmos itself on the ground. This transforms our understanding of the site from a collection of royal tombs into a single, functioning instrument. The pyramids become the focal points, and the Sphinx acts as a fixed reference marker, an anchor for the entire celestial scheme. What does this interconnected design tell us about their ultimate goal? It suggests that the true purpose of Giza was far greater than honoring individual rulers. This was a project designed to harmonize a vast tract of land with the heavens, creating a permanent, earthly domain for the cosmic order they revered. The genius of the pyramid's mathematics was merely one component in a landscape-sized masterpiece. The same simple ratios that create a beautiful chord in music are carved into the very stone of the pyramid. Step inside the king's chamber, and you are standing inside a perfect expression of the octave. Its length is precisely twice its width, that foundational 2-to-1 ratio that in music gives us the most harmonious interval, where a note and its double resonate in perfect unity. This is not a coincidence. Throughout the structure, the proportions of passages and the relationships between chambers mirror the other core intervals of the harmonic scale, like the fifth, with its 3-to-2 ratio, and the fourth, with its 4-to-3 relationship. These are not vague similarities. They are the same whole number ratios that have defined musical harmony for millennia. What could this possibly mean? It suggests the architects were thinking in a language that unified sight and sound. The pyramid was not just a silent monument to be seen, but a structure whose very form was an expression of a universal harmony, a kind of frozen music. This leads to a profound speculation. Was the pyramid designed as a giant resonant chamber, a space where specific frequencies could be amplified and sustained? Could chanting or ritual sounds within these perfectly proportioned rooms have created an auditory experience meant to elevate consciousness or connect with the divine? This idea connects directly to the ancient concept of the music of the spheres, the belief that the planets in their orbits produced a celestial harmony inaudible to human ears. By building these musical ratios into stone, the pyramid's creators may have been attempting to make that cosmic symphony physically present on Earth. They were building an instrument not for human musicians, but for the universe itself, a permanent resonator aligning their sacred space with the fundamental, mathematical song of creation. Yet the silent stone of the Sphinx itself presents a riddle that challenges our entire historical timeline. Deep, weathered grooves cut vertically into the limestone walls of its enclosure, patterns that speak of a force far different from the desert sands. Geologists note that this specific type of erosion is not the work of wind or sandblasting. It is the unmistakable signature of water, and not just occasional rain, but thousands of years of heavy, consistent downpour. This observation leads to a startling conclusion. The last time the Giza Plateau experienced a climate wet enough to create such marks ended more than 7,000 years ago. If the water carved these channels, then the Sphinx, and by extension the entire Giza complex it guards, must be vastly older than the 4,500-year date assigned by traditional Egyptology. This is the water erosion hypothesis, a theory that, if proven, would not just adjust our timeline, it would shatter it. It forces a profound question. Who could have built this monumental complex in an era considered prehistoric, a time before the rise of the dynastic Egyptians we know so well? The implications ripple outward, touching everything we think we understand. The sophisticated mathematics encoded in the pyramid's proportions, the precise astronomical alignments, the mastery of geology and engineering, all of it would have to be re-evaluated. This is not merely a debate about the age of a statue. It is a challenge to the very origins of civilization. It asks us to consider the possibility of a lost precursor culture, a people with advanced knowledge who left their mark on the plateau and then vanished into the mists of time, their legacy inherited and perhaps perfected by the pharaohs who came later. What would it mean if the genius of Giza was not an invention but an inheritance, a sacred trust passed down from a forgotten world? The silent stones are beginning to speak a new language, one read by subatomic particles and laser light. Modern archaeology has moved beyond speculation, employing a suite of non-invasive technologies to see through the pyramid's immense shell. Techniques like muon radiography, which uses cosmic rays to create X-ray-like images of the interior, and high-precision laser scanning that maps every surface to within millimeters, are revolutionizing our understanding. These tools act as a kind of medical scanner for the monument, allowing us to diagnose its internal structure without ever touching a single block. They have already revealed startling anomalies, such as the large void discovered above the Grand Gallery, a hidden space whose purpose remains a tantalizing mystery. This is not guesswork, it is hard data, a new wave of empirical evidence washing over 4,000 years of questions. With three-dimensional modeling, we can now reconstruct the pyramid not as it is, but as it was, testing theories about ramp placement and construction sequences in a virtual sandbox. This technological renaissance provides a critical check on our imagination, grounding ancient wonders in modern science. We are no longer just interpreting texts or measuring surfaces. We are gathering a comprehensive internal blueprint. What new secrets will these invisible probes uncover, and how will they reshape the story we tell about this timeless enigma? This ascent from a broad foundation to a singular point is a profound spiritual metaphor. The pyramid's square base, firmly planted in the material world, represents the physical realm, the domain of the four directions, the four elements, the tangible reality we can measure and touch. Its journey upward along those four perfectly identical triangular faces converges at a single, invisible point in the sky, the apex. This is the realm of spirit, the singular, unifying principle beyond physical form. The entire structure is a map of a soul's journey, a guide for moving from the multiplicity of earthly existence to the unity of the divine. The flawless mathematics governing this path are the most revealing part. The consistent slope, the precise ratios, the unwavering alignment, all declare that this spiritual ascent was not a matter of random chance or chaotic struggle. It was understood as a disciplined, orderly, and fundamentally knowable process. Enlightenment, in this view, was not a mysterious lightning strike, but a calculable destination, a summit one could reach by following the precise and sacred geometry of existence. The pyramid stands as a permanent assertion that the universe operates on a principle of intelligent order, and that by understanding its mathematical language, humanity could build a staircase not just to the heavens, but toward a higher state of being itself. This slow celestial wobble presents one of the pyramid's most profound and debated mysteries. The precession of the equinoxes is a grand, 26,000-year cycle where Earth's axis slowly traces a circle in the sky, gradually shifting which star we see as our North Pole. It is a timescale so vast it dwarfs recorded history, a rhythm felt over millennia, not centuries. Yet, within the pyramid's internal passageways, researchers have noted measurements that seem to mirror this cosmic clock. The lengths of specific corridors, like the descending and ascending passages, are not random. When converted into their original units, the sacred cubits, they yield figures that align with key numbers in the precessional cycle. One passage might represent a single degree of this great circle, while another seems to symbolize the 26,000-year hole. What could this possibly mean? It suggests the builders were not merely marking the static positions of stars, as they did with the shaft alignments, but were attempting to model their slow, majestic drift across the ages. This implies an astronomical tradition built not on one lifetime, but on many, a chain of observers meticulously recording the slow dance of the heavens and passing that knowledge down through generations. They were not just building a snapshot of the sky, but a monument to time itself, encoding the very mechanics of our spinning planet into the heart of their stone mountain. This was a science of deep patience, a civilization thinking in units of time that stretched the very definition of human memory. The sheer scale of this supply chain is almost beyond comprehension. We are not talking about a few hundred stones, but millions of individual blocks, each one a multi-ton piece of a perfect geometric puzzle. Sourcing this material was a calculated decision in itself. The fine white Tura limestone for the outer casing was quarried from across the Nile. The massive granite blocks for the inner chambers were hauled from Aswan, a staggering 500 miles to the south. Each source presented a different mathematical challenge of extraction, weight, and travel distance. How do you solve for a variable like that? You begin with a deep understanding of practical geometry and physics. The quarries were not just holes in the ground, they were carefully mapped landscapes. Workers would have calculated the most efficient angles to cut the bedrock, minimizing wasted effort and material. They used simple levers and the principle of the wedge to free each block, a hands-on application of mechanical advantage that transformed human strength into the power to move mountains. Before a single block was moved, the architects had already solved the equation of its origin, determining the exact volume of stone needed and the most logical place to acquire it. This was mathematics applied to the very earth, turning geology into a predictable resource. The true test, however, began the moment the stone was freed. The journey from quarry to construction site was a logistical ballet orchestrated with mathematical precision. The most iconic image is of workers hauling a massive block on a wooden sledge. But this was not a feat of brute force alone. It was a lesson in reducing friction. Evidence suggests they poured water onto the sand in front of the sledge, a simple act that dramatically lowered the pulling force required. This is a practical understanding of physics, a calculation of weight, surface area, and resistance that made the impossible merely difficult. The routes were not chosen at random. They were the flattest, most direct paths, surveyed and cleared to shave precious days off the transport time for every single delivery. This required a constant, rolling calculation of manpower, of how many men were needed for a 5-ton block versus a 50-ton monolith, and how to schedule these teams so the worksite was never waiting and never overwhelmed. This endless river of stone, flowing for over 20 years, was a masterpiece of applied mathematics. It demonstrates that the theoretical genius of the pyramid's design was utterly dependent on the logistical genius that brought its pieces to the plateau, a symphony of organization playing out one heavy, deliberate step at a time. A perfect geometric form remains incomplete, its final point lost to time. The Great Pyramid we see today is a structure without its summit, a sentence missing its last, most crucial word. This absent piece is the pyramidion, the capstone designed to lock the entire mathematical and symbolic statement into place. Its disappearance is the ultimate unknown variable in the pyramid's grand equation, leaving us to wonder what this final piece was meant to accomplish. What material could possibly crown such an achievement? Many scholars suggest it was fashioned from electrum, a brilliant alloy of gold and silver, chosen for its ability to catch the first and last light of the sun, transforming the pyramid into a permanent, gleaming beacon. This was not mere decoration, it was the final act of a carefully calculated design. The capstone's precise dimensions and its specific angle would have been the most critical measurements of all, the tiny, perfect apex from which the entire massive form derived its meaning. Without it, the pyramid's ascent is literally cut short, its journey from the broad, earthly square to the singular, spiritual point left unconsummated. This missing element compels us to look upward and ponder the completed vision. It represents the transition from the known to the unknown, from the calculable proportions of the base to the intangible idea of a perfect summit. The pyramid's powerful narrative of cosmic harmony and mathematical order begins with its foundation, but it was intended to end with a flash of light at its peak, a final declaration of a genius that reached for the heavens themselves. The Great Pyramid of Giza endures not as a mere pile of stone, but as a complex mathematical manuscript written in dimensions and angles. Its silent language speaks of pi and phi, of celestial alignments and terrestrial proportions, presenting a profound challenge to our modern understanding of ancient knowledge. While scholarly debates will undoubtedly continue, the overwhelming evidence points toward a single, undeniable conclusion. This was a work of sophisticated, intentional design from its foundational base to its missing apex. It stands as a permanent question mark against the timeline of human achievement, forcing us to expand our view of history and acknowledge the breathtaking depth of genius possessed by its creators. This exploration is merely a starting point for your own curiosity. The stones have spoken their piece, but the conversation is far from over. What do these mathematical whispers tell you about our shared past? Share your thoughts on these enduring mysteries in the comments below, and subscribe to continue unraveling the secrets of our world together.